Good morning, students. So let's see structural representation of organic compounds. So in the previous class we have learned about the introduction part of organic compounds. What are organic compounds? They are the compounds having carbons and hydrogens along with other atoms also, like oxygen, sulfur, nitrogen, halogens, etc. So how to represent this organic compounds? There are various ways of representing this organic compounds, and so let's see one by one. So we have complete or dash structure formula representation, and the second one is condensed formula representation, and the third one is bond line structure, and the fourth one is three-dimensional structural formula representation. Structural formula representation. So let's see one by one. Okay. So the first one is complete or dash structure. Complete or dash structure way of representation. So in this method, the electrons which are present in covalent bonds are represented by a dash line. Okay. So the bonds between the atoms, that may be carbon atoms or carbon and other atoms, the covalent bond formed between them by a pair of electrons is represented by a dash line. If the bond present is a single bond, then it is represented by a single dash. If the bond present is a double bond between the atoms, then it is represented by a double dash. If it is represented, if a triple bond is present between the atoms, it is represented by a triple dash. So if the bond present between the atoms is a single bond, it is represented by a single dash. If the bond present between the atoms is a double bond, it is represented by a double dash, and if the bond present is a triple bond, then it is represented by a triple bond. If at all any lone pair of electrons are present, any lone pair of electrons are present on hetero atoms. So what are hetero atoms? That means the other atoms other than carbon. Example, oxygen, it might be an oxygen atom, or it might be a nitrogen atom, sulfur, or halogens. The lone pair of electrons can be represented on the atom as two dots. This is not compulsory, they may be or may not be represented. It is not compulsory to represent them. So they may be represented or may not be represented or shown on the atoms, heterogeneous atoms. Okay. So let's see an examples. We can see ethane, ethene molecule and ethyne molecule. So let's see these examples. So in ethane molecule there are two carbons present, and there is a single bond present between the two carbon atoms having 3 bonds with other 3 hydrogens on each carbon. So this is the molecule, ethane molecule, which is represented in the complete or dash structure method, way of representation. If we take the example of ethene molecule, ethene, there is a double bond exists between 2 carbon atoms, and carbon forms 2 single bonds with 2 hydrogen atoms. So this is the complete or dash structure of ethene molecule. Now let's see ethyne example. There is a triple bond present between 2 carbon atoms. So it is represented by 3 dash lines and 1 single bond with each hydrogen atom. This is the structure of ethyne molecule. So this is the way of representing complete or dash structure. If we take another example of methanol, what is the formula of methanol? CH3, and there is a bond present between oxygen and hydrogen. So it can be written as single bonds between all the 3 hydrogens in oxygen, and or else there is another way of representing the lone pair of electrons which is present on the carbon. So it can be represented as dots. So may be represented or may not be represented. This is the meaning. So if the lone pairs are present on the heterogeneous atoms, it may be represented in the form of dots around that atom, heterogeneous atom, or it can be omitted also. It may not be represented also. It will be fine. So this is the way of representing the complete or dash structures. Now let's see the second way of representation, that is condensed. Let's see condensed way of representing. So condensed structural formula, method of representing. So here we can see in the dash representing structures, covalent bonds were represented as dashes, but in condensed structural formula these dashes are omitted. Or they are not present or removed. If any identical groups are present, identical means same types of groups, same groups are present, then so same groups are attached to a central carbon, or any atom, then they are represented by subscript. They are represented by a subscript. Okay, we'll see. Let's see an example. Again we will take the examples of ethane molecule, ethene, ethyne and methanol. So let's see the examples. So we don't use dash lines to represent the bonds between them. We will simply write as CH3 for ethane molecule. For ethene, a double bond is present between the 2 carbons, so it is represented like this. If a triple bond is present between the carbon, it should be represented like this. So this is the way of writing condensed structural formula. For methanol, it can be written as CH3OH, CH3, or it can be also written as like this, CH3OH. So this is the way. Let's see one more example. Let's see one more example of representing condensed structural formula. Here there is a compound where we have CH3, CH2, 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 CH2 and a CH3. Here you can see that, observe that there are identical groups present. See, this is one group, 2, 3, 4, 5 and 6. We have 6 CH2 groups attached. So we can write this formula as CH3, CH2 taken 6 times CH3. So it can be written in condensed way of representation like this. So this is an elaborated way, but can be written as a condensed way.